Hi everyone, welcome back. In this video, we're going to implement the Singleton pattern in Dynamics 365. We'll capture this by creating what is called a parameter table. Basically, I'll show you exactly how to structure the table, enforce that single record rule and use it to store global settings for our new module. Also, a quick note, this video marks the start of phase 2 of our playlist. I'll spend just a minute showing you the roadmap for this next batch. But if you are only interested in the Singleton pattern implementation, feel free to skip ahead using the video chapters. So phase 1 videos 1 through 8 is already out and covered the technical foundation. Now in phase 2, we are covering videos 9 through 20. So looking back at the first 8 videos, phase 1, we established a pretty massive technical foundation, right? We set up the full development environment with LCS and DevOps. We extended tables and forms. We did custom validations with chain of command. We built batch jobs using the system operation framework. We exposed data through OData APIs. We set up business events and Azure Logic apps. We configured CI pipelines in DevOps. And we connected everything to Power BI dashboards. Now for this next batch, these 12 videos we're going to build directly on top of that foundation. We'll create parameter tables to store global settings. We'll build custom number sequences for auto-generated IDs. We'll design complex forms with the details master and table of contents patterns. We'll link header and line tables with relations. We'll build SSRs reports, consume external APIs, and import data using custom mapping in DMF. We'll set up security roles, duties, and privileges. We'll create workflows with submit and approval, and we'll finish with unit testing using the Sisters framework. Okay, so that covers the roadmap. Now let's get back to the Singleton pattern. In Dynamics, we also call this a parameter table. Basically, the goal here is to create a table that holds exactly one record, right? And we simply use that record to store global configuration for the entire module. To help us understand this better, let's look at our specific project. Let's consider our fictitious client, Bluestone Industrial Components, right? Just imagine for a second, they are a large B2B manufacturer making heavy machinery like pumps and compressors. Now, when they sell a piece of equipment, there is often a warranty attached to it, right? The warranty period varies depending on the type of product and the service contract the customer has. So the business team told us, look, we have 2 warranty tiers. Standard customers get 365 days of warranty. Gold customers get 720 days. And these numbers, their global settings, they apply across the entire system, not just one transaction or one customer. Now here is the question, right? Where do you store global settings like this in Dynamics 365? I mean, you could hard code them directly into your X++ code, but then every time the business wants to change the warranty period, a developer would have to modify the code and redeploy. That is not practical. In fact, it is bad practice. So the standard approach is to create what we call a parameter table. Basically, it is a special kind of table that stores configuration values. And the key characteristic of a parameter table is that it only ever has one record. That single record holds all your global settings. This is called the Singleton pattern, and it is used everywhere in Dynamics 365. Examples include general ledger parameters, accounts receivable parameters, inventory and warehouse management parameters, and so on. You've probably seen these before, right? So when a functional consultant or power user needs to adjust a setting, they just open the parameters form, change the value and save. No code changes required. Okay, so today we are going to create a BICWarrantyParameters table that follows this exact same pattern. The table will store 2 values, the number of warranty days for standard customers and the number of warranty days for gold customers. But here is the important part, right? We need to enforce that only one record can ever exist in this table. That is what makes it a singleton. If someone accidentally tries to insert a second record, the system should block it. And we also need to prevent deletion of the existing record. Okay. So how are we going to enforce this? Okay. Basically 2 things. First, a unique index at the database level. And second, X++ logic in the validateWrite and validateDelete methods for user-friendly error messages. All right. Enough theory. Let's actually build this. I am going to switch over to my development VM now. Okay, so I have Visual Studio open and I have my existing BIC customer management project loaded. This is the same project we've been using throughout the series, right? Now, before we create the table, we first need to create the fields that will go inside it. And those fields need extended data types or EDTs. Basically, an EDT is a reusable data definition. It specifies the type, label, and other properties for a field. So we're going to create 2 EDTs, one for standard warranty days and one for gold warranty days. Let me start with the first one. All right. So in the Solution Explorer, I'll right click on my project, then choose Add and select New Item. This opens the Add New Item window. Okay. So from the list on the left, I'll start by expanding the Dynamics 365 items node. Then right underneath that, I'll click on Data Types. Now over in the middle section, you'll see EDT integer. That is exactly what we need. So I'll select that. At the bottom for the name, I'll put BICWarrantyDaysStandard. This follows our naming convention where we prefix with BIC for our project, right? And the name itself describes what the field represents. Then I'll click add. Okay. So the EDT is now created and Visual Studio has opened it in the designer. Now I need to configure its properties. So let me expand the properties. Okay. So for the label property, I'll set it to standard warranty days. This is what users will see on the screen. Nice and descriptive, right? Next, I'll add a help text. This appears when users hover over the field. I'll set it to number of warranty days for standard tier customers. It gives context to anyone using the system. Alright, that is it for the first EDT. Now let me create the second EDT for gold warranty days using the same process. So again, I'll right click on the project node, go to add and select new item. Once the dialog opens, I'll make sure data types is selected on the left. Now from the list in the middle, I'll pick EDT integer again. And for the name down here, let's call this one BICWarrantyDaysGold. Looks good. So I'll click add. Okay. So for this one as well, we need to update a couple of properties. First, for the label, let's set it to gold warranty days. Then moving up to the help text, I'll enter number of warranty days for gold tier customers. Okay. So now we have both EDTs ready. You can see them both listed under the data types node in our project. Next, we're going to create the actual table that will use these fields. I'll right click the project, choose add, then new item. This time I'll keep data model selected on the left side and choose table in the middle. For the table name, I'll use BICWarrantyParameters. This follows the naming convention for parameter tables in D365, right? The table name ends with parameters. Okay, click add. Alright, the table is created and Visual Studio has opened the table designer. You can see the structure on the left with nodes for fields, field groups, indexes, relations, delete, actions, and methods. Now I need to add our fields to this table. So in the Solution Explorer, I can see my two EDTs that we just created. The easiest way to add them is just drag them onto the fields node. So I'll drag BICWarrantyDaysGold and drop it on the fields node. See, a field is automatically created with the same name. Now I'll drag BICWarrantyDaysStandard and drop it on fields as well. Great. So both fields are now part of the table. Under the fields node, we can see them listed there. Each field inherits the label, help text, and data type from the EDT we created. Now, here is the important part, right? To implement the Singleton pattern, we need a special field that I'm going to call the key field. Basically, the idea is to create a field that always has the same value and then set it as a unique index. This prevents duplicate records at the database level. Let me add that key field. So I'll right click on the fields node, select new, and then choose integer. This creates a new integer field. Now, if you look inside the properties, you'll see it has a default name. Let me rename that. I'll just call it key. Okay, so I'll just scroll up and here we can find the visible property. I'll set visible to. No, we don't want users to see or interact with this field. It is purely for internal enforcement, right? Now I need to create an index on this key field. This is what actually enforces the uniqueness at the database level. So I'll right click on the indexes node of the table and click new index. So under the properties pane, we can see it has got a default name. I'll rename this to index key index. Now in the properties window, the most important setting is allow duplicates. I'll set this to no. This makes it a unique index, meaning the database will reject any attempt to insert two records with the same key value. Okay. Now I need to add the key field to this index. So I'll select the key field from the fields node and just drag it onto the KeyIdx index. See, it now appears under the index. Perfect. So now the database will enforce that we can only ever have one record with key equals 0. Since integers default to 0, every record we insert will have key equals 0. And the unique index prevents a second record. That is the trick. Alright. Now let me configure some table level properties. This is important for parameter tables. I'll click on the table name BICWarrantyParameters in the designer to select the table. Then under properties window, I'll scroll up to find the label key. I'll set the label to warranty parameters. This is what users see in the UI. Now just below that for title field 1, I'll enter key. This is optional but good practice. Then I'll scroll down to find the table group property. And here I'll set it to parameter. This tells the system that this table contains configuration data. Okay. Now for CacheLookup, I'll set this to EntireTable. This is perfect for parameter tables because, the system will cache the entire table in memory. Since we only have one record, loading the entire table is very efficient and gives us fast access. So just to elaborate on CacheLookup options, found is typically used for master data where records are accessed frequently by ID like customer groups. NotInTTS is similar, but it ensures the cache is only used outside of transactions. This is usually safer for larger master tables to ensure data consistency. Then we have none, which we use for transaction tables because the data changes too fast to cache reliably. And finally, EntireTable, which is what we are using here. It loads everything into memory at once. It's perfect for parameter tables, but impossible for large datasets. Next, I need to set up the index properties. I'll set clustered index to KeyIdx, which is our unique index, and I'll also set primary index to KeyIdx. Now, these are two different concepts, so let me quickly explain. Basically, the primary index is logical. It tells dynamics which field uniquely identifies a record, kind of like the main ID card for the row. The clustered index is physical. It actually determines the order in which data is stored on the hard drive. For a parameter table, they are usually the same. Let me save the table now with Ctrl+S. Okay, so the table structure is complete, but we're not done yet. Remember, we need to add X++ logic to actually enforce the singleton pattern with user-friendly error messages. See, the database index prevents duplicates, but if someone tries to insert a second record, they would just get a cryptic database error. We want to show a clear, helpful message instead. So we're going to override two methods, validateWrite and validateDelete. Alright, so I'll right click on the BICWarrantyParameters table and select View Code. Okay, so now Visual Studio has opened the code editor and I can see the class definition. It just shows public class BICWarrantyParameters extends common with an empty body. Now I already have the code prepared, so I'm just going to paste it inside this class. Let me do that now. Perfect. So the code is now pasted. Let me walk through what each method does, starting with validateDelete at the top. So basically what we're doing here is we just return check failed with a message saying the warranty parameters record cannot be deleted. The check failed function displays an error message to the user and returns false, which blocks the delete operation. Alright. Now let's move on to the validateWrite method. This one is a bit more complex because we need conditional logic to enforce the singleton pattern. Okay, so what do we want here? We want to allow the first record to be saved successfully but block any duplicate records. So the logic needs to check if we are inserting a new record and if a record already exists. Okay, so first we declare two variables, the boolean ret to store the validation result and existing record to query the database. Then we call super to run the standard validation logic. So if super returns true, meaning the validation passed, right, then we check if this .recID is empty. If recID is empty, that means this is a new record being inserted, not an existing one being updated. So if the standard validation passed and this is a new record, we query the table to see if a record already exists. We use select first only to get just the recID of any existing record. If existing record.recID has a value, that means the record already exists in the table, right? In that case, we return check failed with a message saying a warranty parameters record already exists. You cannot create another. So basically, if a record exists, we return false and block the insert. If no record exists, we return true and allow the insert. Now we have one more method to add, a static find method. This is a standard pattern in D365 that provides a convenient way for any other code in the system to retrieve the single record from this singleton table. So the find method is a public static method that takes a boolean parameter called _for_update. This is important for locking purposes when the caller needs to modify the record. Inside the method, we declare a variable to hold the result. We use select for update if the caller needs to update the record. Then we use select first only with the KeyIdx index to retrieve the single record where key is 0. Finally, we return the parameter buffer. This gives the caller the single parameters record or an empty buffer if no record exists. Alright, the code is complete. Now we need to build and synchronize the database. The build compiles our code and checks for errors. The synchronization creates the actual table in SQL Server. Let's do it. So I'll right click on the project and then click build. The build starts running and you can see the progress in the output panel at the bottom. So we wait for a few seconds and then this message will appear saying build succeeded with 0 errors. Perfect. Now I'll synchronize the database. I'll right click the project and click synchronize BIC customer management with database. The synchronization is running. This might take a moment as it creates the table and index in SQL. So after a couple of minutes, you'll see this message stating database synchronization completed. Now we have our table created in the database. So let's verify that everything works as expected. Alright, so I'm going to use the table browser to insert a test record and verify our singleton logic. In Visual Studio, I'll right click on the table BIC warranty parameters and then click open table browser. This opens the table in a browser window. Right now it is empty because we haven't created any records yet. Let me create our first and only record. I'll click new to add a row. Alright, So the new record opens. Now let me just expand these columns a bit so you can see the field names properly. There we go. So in the standard warranty days field, I'll enter 365, and in the gold warranty days field, I'll enter 720. And notice the rec ID field is 0, which means this is a new record that hasn't been saved yet. Now let me save this record by clicking the save button at the top. Okay, the record is saved successfully, and see the rec ID field now has a value which confirms it has been saved to the database. Alright, now let me test the singleton enforcement. I'll click the new button to try adding a second record. See, a new record appears with default values like 00. Now let me try to save this by clicking the save button, and there we go. See the error message in the info log. It says a warranty parameters record already exists. You cannot create another. Our validateWrite logic is working perfectly. The system blocked the duplicate record exactly as we designed it. Now there is still this unsaved empty record showing in the form. So let me clean that up by clicking the delete button. Okay, so now we only have our one saved record left in the table. Alright, now let me test the delete protection. The saved record is already selected, so I'll click the delete button to try deleting it. And there we go. The info log shows the error message. The warranty parameters record cannot be deleted. Perfect. The validateDelete logic is also working correctly. Our singleton enforcement is complete. Okay, so to recap what we built today, we created a parameter table called BICWarrantyParameters that stores global warranty settings for the warranty management module. We implemented the singleton pattern to ensure only one record can ever exist in this table. We used a combination of database level enforcement through a unique index and code level enforcement through the validateWrite and validateDelete methods. And we created a static find method that provides easy access to this single record from anywhere in the code base. This pattern is fundamental in Dynamics 365 development. You'll see it used in almost every module. In the next video, video 10, we're going to build on this. We'll create a custom number sequence so that our warranty claims can get auto-generated IDs. Thanks for watching, and I'll see you in the next one.